Okay, so what kind of came out of the integral test that we've looked at is this idea of a p-series. And when we talk about a p-series, we're basically talking about a summation. Let's do a k equaling 1 to infinity of 1 over our k to a power. Okay, so our power series. Now, when p equals 1, we have what we call the harmonic series. Now, for any of these, just keep in mind, technically you can use your integral test on, but if you recognize them, then you can go ahead and use some convergence and divergence ideas for these power series. So let's take a look at a theorem very specific to harmonic series. And this came out of what we did on our first integral test. And it simply states the harmonic series which is a summation, k equaling 1 to infinity of 1 over k, which is 1 plus 1/2 plus 1/3 dot dot dot, diverges. And that's what we learned when we applied our integral test, that this series diverges. Even though the terms approach 0, the series, because you're adding all of them together and it doesn't quite approach 0 fast enough, like we saw in 1 over k squared, this series diverges. This is a very, very special case of our p-series. Now, well, we saw when p is 1, as in the harmonic, it diverges. We also saw when p was 2, in the case of 1 over k squared, it converges. So where is the cutoff? Well, it happens to be at 1. So here we are, the p-series. And I mistakenly called it power series. Power series is something a little more specific that we're going to get into in the next chapter. So we're just going to call this the p-series. The p-series, summation k equaling 1 to infinity of 1 over k to some power. Well, again, what we saw those two examples is it depends on how quickly it approaches 0, right? So it converges when p is greater than 1 and diverges when p is less than or equal to 1. So again, if you don't remember this, you can apply your integral test. This is a very special case, this particular p-series, but it can come in handy for series that resemble p-series. So let's look through just a couple quick examples, keeping in mind that as long as your p-value is greater than 1, you converge. If your p-value is less than or equal to 1, your series diverges. So here we are. First one, we'll just go through 3 quick examples. Example 1, summation k equaling 1 to infinity of k to the negative 3. Well, yeah, just quickly rewrite it, because to do a p-series has to be 1 over. Once you write it in the correct form, you quickly see, and what you could write on your test is simply, okay, p equals 3, which is greater than 1. So by p-series test, the summation of k equaling 1 to infinity of k to the negative 3, because it is greater than 1, it converges, right? That's it. That's all the work you have to do if you were to get something like that on the test. If you don't recognize that, you could, again, go through your integral test and arrive at the same answer of converge. Example 2, let's do the summation. N equaling 1 to infinity of 1 over 4. Sorry, not 4. It's supposed to be 4th root. I made my 4 way too big. There we go. 4th root of n cubed. Again, it's a matter of simply rewriting it. Now, make sure you know how to write. Your root is your denominator, so it's actually 3/4. You have to get that correct. And then off to the side, I can say my p is 3/4, which is clearly less than 1. So again, by p series, test the summation, n equaling 1 to infinity of 1 over 4th root of n cube diverges. All right, but in order to show that, you have to show me you recognize what p is. So, what do I expect to see on a test? Well, I expect to see it rewritten. I expect to see what your p is, and then I expect you to tell me that you actually used the power series test. All right, one more. And I said this video will be short. Example 3. So let's start at a different point. Let's do summation k equaling 4 to infinity of 1 over k minus 1 squared. All right, so to actually use your p series, you can't have a k minus 1. But let's think about this for a minute. I'm starting at 4. Well, if I were to plug in 4, what does this series look like? Wouldn't I get 1 over 3 squared plus 1 over, when you go to 5 minus 1, 4 squared? This is when k equals 4, k equals 5. We can rewrite our series, right, as 1 over k squared, as long as I start k at 3. Notice, it is the exact same series. 1 over 3 squared plus 1 over 4 squared, dot, dot, dot. Okay, so you can play around with that a little bit by taking away the minus 1. I just had to bring the starting value from 4 down to 3. Then you say, well, p equals 2, which is greater than 1, converge. So by p series test, summation, my original 1 over k minus 1 squared, converges. That's it. So again, this is one of those tests that if you see it, great. It's very useful. It's very useful in a couple things, and it's useful in some things we're going to do in the next section as well. So that's your p series.